Hello, my name's Alex, and I was a physics major. I graduated my degree in physics in the fall semester of 2017, and I'm currently in grad school right now for physics as well. I'm also a high school teacher who teaches physics at the moment as well. So this is my advice as someone who's a physics major, someone who now teaches physics, and someone who's now in grad school physics on how to be successful as a physics major. So let's get started. First piece of advice that I would want to get you is to attend class and take good notes. Taking good notes means that you're writing everything that's on the board, writing down what the equations mean, and drawing all the diagrams and labeling them based on what the professor says, all right? Because it's easy to go, oh yeah, I'm gonna be able to remember what that diagram was or what's happening here. But then, a week later when you're studying for your test or you're trying to complete your homework set, then you might not understand everything that's in your diagram. So take good notes, all right, and label them. Another piece of advice in taking notes, and this is something that I wish I would have done earlier on, but a lot of my classmates did, now that I recognize how good it is to buy the notebook with the graphing paper note, all right? Because especially in like classes like upper-level mechanics or electrodynamics, the graphing paper allows you to actually draw diagrams neatly and have clear dimensions, especially when you work in 2 dimensions, 3 dimensions of physics, all right? So that would be also a good piece of advice there. My second piece of advice is to review your notes outside of class and either rewrite them or type them up. What I used to do is I used to go through my notes and type them up in a Google Doc so they're saved in the cloud. And that's another thing you should do too, right? So when we take your notes and you're studying them, if you don't want to retype them, and if you have really good handwriting, I don't, so that's why I type them, but if you have really good handwriting, what you can do is use your camera, take a scanner app, and scan your notes into your Google Drive. And organize them in folders based on class and based on topic, because when you go back and do your homework, or later on in your physics studying career, you might need those notes. Or it'd be easy to share for your classmates as well, who may not have attended class. So organize your notes, scan it, save it, all right? And once again, go back, review your notes, retype them, because that's how you're able to process it. Because when you're in class, you're passively taking the information. When you're retyping it, you're going back and you're reevaluating what happened in class, and you're testing your understanding, and you start to identify gaps, and we're like, wait a minute, what was happening here? So you're able to identify what areas that you need to go back and research and understand. All right, so my third piece of advice would be to read the textbook. And this was my mistake starting out early on as a freshman studying physics, is that I didn't take the time to read the textbooks entirely. So the textbook is going to help you understand the concepts, but they also have some good derivations that's going to help you understand the math as well and where the math comes from. All right. Secondly, I would recommend is finding a supplemental textbook to the one you have, because sometimes seeing things explained differently or derived differently helps, and going back and rereading a concept in one textbook and reading again in a second textbook allows you to better understand the concept and identify your gaps in knowledge. Right? And I know textbooks are expensive, right? I got mine off used books on Amazon, and you didn't hear it from me, right? I'm just gonna put this out here. PDFdrive.com has a lot of physics textbooks that you can just download the PDF. Once again, you didn't hear that from me, all right? All right, so this next piece of advice is one of the most important pieces of advice that I can give you. And this is a common mistake that many people make, especially in the entry-level physics classes and early on, that will be your pitfall if you don't address it early, all right? And that is trying to understand the mechanics of the problem and not the concept behind it. And here's what I mean, and I see this as a physics teacher myself now, is that a lot of students, when they're studying for a midterm or a final or doing the homework sets, is that they try to pick a format of a problem and try to memorize the steps and how to solve that problem. Okay, step 1, write down this equation. Step 2, substitute this. Step 3, solve. And that may work in your entry-level physics classes, but once you get up to your 300, 400 level, 500 level classes, that no longer applies, because those problems get a lot more complex and require you to do multiple things. For example, you might have a problem you to use the conservation of energy, and that will help you solve the problem faster. Or you might have a problem and say, okay, well, wait a minute, I have to apply Green's theorem or Stokes' theorem to help mathematically solve the problem easier, alright? And so if you don't understand the math concepts and the physics concepts behind a problem, then you're not going to be successful, because your knowledge is a toolbox on how to approach problems, alright? So when you're studying the concepts, make sure you're fully understanding the concepts and how to apply it in different situations, because once again, in your low level classes, your 100, 200 level classes, yeah, you may be able to memorize a problem solving method. However, in your upper level classes, they expect you to have the knowledge, the background knowledge, to apply the concepts to a more difficult problem, and being able to come up with your own problem solving method, because it's not always do X, do Y, do Z. It may be more complex than that. So once again, know the concepts and not just try to memorize the mechanics of how having to solve a problem. Number 5 here is that YouTube is your friend. And I mean it, YouTube is your friend. Now, it is important to go to class, yes. It's important to take good notes, yes. However, that alone is not going to make you understand the concept entirely, alright? So, when you're in class, what you're doing is that you're passively taking notes and passively taking information. All you're doing is trying to catch your notes to go back and study later. Because in class, professors go, alright, they have a lot to teach in a small amount of time, alright? So YouTube gives you the option to go back and watch someone, be able to follow through at your own speed. If you missed something, going back to see it again. And if you don't understand it, go back and watch it again. If you don't understand how they got to the next step, go back and watch it again until you understand how they got from each step to each step to each step. I've also used YouTube to watch other lectures, because sometimes seeing someone else explain a concept helps you understand the concept better. We all have professors where sometimes they explain things really well, and sometimes they don't explain things very well. I mean, even like a 2-minute video on the basic of a concept can help you build a foundational knowledge to go back to use and solve a problem. So don't shy away from YouTube. I would also add that subscribing to a service like Chegg.com or Quizlet Plus is worth it, because textbook solutions are a great way to learn how to do physics. And they're not meant for you to just copy down, do your homework, and turn it in, because you're not going to learn anything by copying it down and turning it in when the midterm final comes along. However, it is a good way to see how problems are approached. All right, so some problems do have a methodology to approaching them. For example, in electrodynamics, sometimes it's just best to start with Gauss's law. All right, so tech solutions are great too, as long as you're using them to understand a problem and not trying to complete your homework sets. All right. The next tip is a tip for studying, and it may be the one tip that will single-handedly put you above your classmates. All right, and that is to, when you're studying and you think you know a concept, teach it to yourself or to just somebody else. And what I do is that I record a video of me explaining how to solve a problem or explaining a concept. Go ahead, this is just for me, all right? But the point is that when you have to go back and you have to teach it and explain to somebody else, or explain how to do a problem in physics, you are able to identify your own gaps in knowledge where you still struggle to understand. And that gives you time to go back and re-enhance, and then go back and re-teach again. Because teaching is an active process, right? So when you're in class, you're taking notes as passive. However, when you're teaching it to somebody else, you're actively using that information, and you're reinforcing that information and those problem-solving strategies in your brain. All right, this is called the Feynman technique, named after Richard Feynman, who was a brilliant physicist and a great lecturer. If you've not watched the Feynman lectures on physics, you are missing out. So please go do that right after this video, if you finished all your homework, of course. All right, so get to know your professors and your classmates. Most physics programs are usually pretty small in numbers, which means that your professors will get to know you personally. They'll know your name, your personality, your likes, dislikes, and you actually will make good relationships with professors as well as your classmates, because the people you are 200 level classes with are the same ones you're going to be in 300, 400, and sometimes you just go class to class with those people. And so what you need to do is you need to first of all get everybody's contacts, start a group meet or start a group chat where people can share information, ask questions, because sometimes it's okay to ask your classmates, hey, who solved number 5? Can someone help me with number 5? People are usually okay sharing the solutions to help you on the homework. Alright, or people will say, hey, I heard this is going to be on a test. Get to know your classmates, network with your professors and your classmates, because they are going to be your biggest support system. You cannot go through physics on your own. You're going to need a support system, someone you can talk to, someone you can have a relationship with, right? And that brings me on to my next point. So I'm going to jump right into my next point. Number 8. Join the Society of Physics Students if your school has one. If not, stop that chapter. Society of Physics Students is a great way to get involved in physics research, physics networking event, have cool talks on physics, alright, and also form study groups. Alright, so please join your Society of Physics Students. It's also look great on a resume when you're applying to grad school. Alright, okay, tip number 9 is going to be do research as an undergrad. This is something that I did not do, and I regret it every day. Alright, because doing research as an undergrad, one, to help you get research experience, which looks great for grad school. It's going to allow you to network with professors who are going to be the ones to write your letters of recommendations for grad school and potential future job offers. Alright, and it also gives you the chance to start something that may turn into be your senior project or your senior thesis ahead of time. Because most physics programs, when you graduate, you have to do your own research project. And that can either be in a lab or it can be a literature review. But you have to demonstrate some knowledge on some concept, and then you present it, and they question you, see how much you actually know, and they decide if you pass or not based on that. Alright? So that's why you do research as an undergrad. And then it just occurs junior or senior year. But as a freshman and sophomore, most universities do have smaller programs, just get your feet wet in the summer maybe, to do small things on research teams, to also help you prepare for doing research as a junior or senior. Alright, so do research as an undergrad. Alright, tip number 10 is to learn LaTeX. And you may not know what LaTeX is yet. Don't worry, I'm going to tell you what it is right now. LaTeX is a programming language, well, actually, technically a document markup language that is used to write scientific papers and lab reports. And it sounds daunting at first, and it looks daunting at first, but once you learn it, it makes typing notes and writing papers and lab reports so much easier. Because when you do research, especially if you want to go to grad school, or when you're doing a senior project, you're going to want to learn LaTeX, because when you publish something in the scientific community, you usually write it in LaTeX. And like I said, writing notes and lab reports gets easier because once you understand the markup language, it just allows the formatting for you. And it also prints out equations so much more beautifully than Word or Google Docs, right? You can tell when an equation or a paper is written in LaTeX versus a word processor, alright? So, learn LaTeX, and there's 2 free services online that you can actually start using it. I mean, yes, you can download it, but nowadays everything's in the cloud. There's no need to download LaTeX on your computer. I use Overleaf personally, but a lot of people also use Share LaTeX, and as of recently, they've actually merged to the same company, but still 2 different platforms. So I recommend Overleaf or Share LaTeX. Just go through, dabble with it. What I did as an undergrad in my early 200 level lab classes, I used it for my lab reports. At first, it made my writing lab reports a little bit longer, but when I turned it in, it looked a lot more professional. And once I got the hang of it, of writing lab reports and papers in LaTeX, it actually saved me time later on. Alright, so learn LaTeX. And those are the best pieces of advice that I can give you. As someone who went through a physics program, made a lot of mistakes as an undergrad, who's now in grad school, who now teaches physics. Alright, I learned a lot through my journey of getting my physics degree, and I hope by giving you this information that you can be successful and you avoid the mistakes that I've made, and you can be a great physics student. And remember, physics is hard. Physics is hard for everyone. What it takes to succeed is perseverance. No one understands physics the first time around. No one understands math the first time around. Alright, it's okay to struggle, because when you struggle, that's how you learn. The thing is, you have to stick with it. You have to practice. You have to persevere. Do not doubt yourself. Alright, it's okay to struggle. Physics is hard, but using my advice and being confident in yourself is gonna make you be successful. Alright, so I wish you best of luck, and hopefully in 4 years or how long it takes, you're walking out with a physics degree. Best of luck to you.